Hello people, good morning, welcome to another video. Today I'm gonna talk about systems of linear equations and how would we solve them. That's what we've done in the lecture 5, and I'll go straight into this because I find this topic easy, but you really need to be careful and really pay attention to what you're writing when you're solving systems of linear equations, because it's really easy to make a mistake. So there are three methods for solving systems of linear equations. There's Gauss-Jordan elimination rule, there's Crammer rule, and there are matrices. So as you may notice, I crossed Gauss-Jordan elimination rule, and for two reasons. First reason is that we were already explained this rule in class, so I will not focus on it in this video. And also the other reason why I'm not going to focus on it, because I find this rule the hardest one and the one where people can make most mistakes. So Gauss-Jordan elimination rule is the rule that I never ever use, so I will not talk about it in this video, but I will talk about Cramer's rule, which is really easy, and matrix rule, which is also really easy. So let's go now to see what I mean by Cramer's rule, and we're gonna start with the example immediately so that I can actually show you what I mean by that. So this example is from our worksheet 5. It's exercise 1. So x minus 2y plus 3z equals 7 would be first equation. Second equation, we have 2x plus y plus z equals 4. And third equation would be negative 3x plus 2y minus 2z to be equals negative 10. And our question is, what would be the values for x, y, and z? So let's take a look at the Cramer's rule now. Here. So Cramer's rule we usually write in this sort of a matrix. We're first calculating delta. This is called delta. This one is really important, and you will see in a minute why. So how do we approach the solution? So we open a little so-called matrix over here, and when calculating delta, we put our values for x, y, and z in this case like this in a column. So you will have our values for x. We see here is 1, so here we have 1, 2, 2, and negative 3. Then also values for y, which are negative 2, 1, 2, and values for z, 3, 1, negative 2. We draw a little line just to separate it, and on this side we just rewrite first two columns. So we would, in this one, we would rewrite our x, and here we would rewrite our y. And then what do? We apply something called Saras's rule, that says that we multiply each number, where possible, with the other two numbers that are lower and right from it. So what do I mean by that? So in order to get our delta, we would multiply 1 times, so we go down and write 1 times, down and right, negative 2. Okay, then we would take a look at this one. We multiply negative 2, and then we go down, right 1, then down, right negative 3. So negative 2 times 1 times negative 3. Then we go here, 3 times 2 times 2. And we don't go any further. Why? Because to apply Saras's rule, we need to have three numbers that we would multiply. So in that case, we would not multiply this one by 1 and nothing here. And now this is exactly why I rewrote these two columns, so that we can actually have the possibility to apply Saras's rule. So, and then once we multiplied for this one, we would go from down to up and multiply that as well. So we would have 3, no, negative 3, sorry, times, now we go up to the right, 1 times 3, 2 times 1 times 1, and negative 2 times 2 times 2. Okay, now we're just going to take a look at what signs do we do. When we're going from up to down, which is our green line, we plus them. When we're going from down to up, we minus them. Okay, so just not to confuse you, let's go straight into solving this delta so that you actually see what I mean by this. It's really not hard, I promise you. So, here's what we have. So what did we say previously? So, 1 times 1 times negative 2 here, plus negative 2 times 1 times negative 3, plus 3 times 2 times 2. Now the sign changes because we're going now from down to up, and we'll have negative 3 times 1 times 3, minus again 2 times 1 times 1, minus again negative 2 times 2 times negative 2, and that's it. And now we just calculate it and simplify it. So we'll have negative 2 plus 6 plus 12 plus 9, because this would give us negative 9, minus and minus gives us plus, minus 2 minus 8, and we would get that our delta equals 15. Now when we know the delta, we're gonna calculate the others. So now we're looking for delta x, and delta x is the same thing as delta. It's just that there's one small difference. Instead of writing now x, y, and z, we would write our free factors on the place where our x used to be in our delta. And what are our free factors actually? Our free factors, 7, 4, negative 10, are actually our solutions that were given in our exercise. So, So we're gonna go back to our this one, and now we write free factors y and z. Again, we draw this line, and then we write our two columns. So here we would have our free factors, and here we would have y. And how do we solve it? We solve it exactly as we did for delta. So 7 times 1 times negative 2 plus negative 2 times 1 times negative 10 plus 3 times 4 times 2 minus negative 10 times 1 times 3 minus 2 times 1 times 7 minus negative 2 times 4 times negative 2, which is exactly what we wrote here. And now when we solve this and simplify it, we would get that negative 14 plus 20 plus 24 plus 30 minus 14 minus 16 would give us 30. So that's a value of our delta x. Now, knowing that, we're gonna solve delta y. Once again, it's the same thing. We write our x values on the place where we used to write our y values. We're gonna write our free factors, then z, then separate, and then copy first two columns. So what will we have? 4 times 1 times negative 2 plus 7 times 1 times negative 3 plus 3 times 2 times negative 10 minus negative 3 times 4 times 3 minus negative 10 times 1 times 1 and minus negative 2 times 2 times 7. So when we simplify this, we would get negative 8 minus 21 minus 60 plus 36 plus 10 plus 28. And the solution for delta y, will be negative 15. There's only one more delta to calculate, which is delta z. So the approach exactly the same. We put our x values here, y values here, our free factors, divide the matrix, and then we rewrite our first two columns. So what will we have? 1 times 1 times negative 10 plus negative 2 times 4 times negative 3, sorry, plus 7 times 2 times 2, minus negative 3 times 1 times 7, minus 2 times 4 times 1, minus negative 10 times 2 times negative 2. When we simplify this and calculate it, we would get negative 10 plus 24 plus 28 plus 21 minus 8 minus 40, and we would get that our delta z is equals 15. So now we have values for delta x, delta y, delta z, and delta. So how are we going to use these values to calculate our x, y, and z? Easy. So in order to calculate our x, we would divide delta x and delta. So the value of our delta x is 30, divided by the value of our delta is 15, and we would get that x equals 2. The same principles of solving we would apply for y and z. So delta y divided by delta equals negative 1, so negative 15 and 15, and z equals delta z divided by delta, so 15 over 15 equals 1. So what would our solution be? We would write that x, y, z equals 2, negative 1, and 1. And this is how you solve the system of linear equations for using Cramer's rule. Okay, I hope this is clear. This requires just a bit of practice. I personally find Cramer's rule easiest out of these three rules. And now we're gonna take a look at the matrix. So the example that I'm gonna work on, actually exercise, is from worksheet 5, exercise 2. So what does matrix look like? So this is kind of a, let's say, the way that it should look like in the end. So it's the same system of rewriting this as we had in our Cramer's rule. Just the only difference is that we do not write these we do not rewrite these two columns here. But what do? Let's take a look. So when we finish, and how do we know that we finished our matrix? We want in our second row to have 0 here, and in our third row we want 0 here and 0 here. Our A, B, and C would be values that we would get in the end on this side, and then based on that we can calculate. These little hashtags are just like numbers that we would have here. We can calculate the z equals c, and then we calculate for z. Then we include that z value into this one. Then we have to calculate y, and then we include both z and y into this one to calculate for x. It does sound a bit complicated, but I'm gonna show it to you in example immediately so that you actually see that it's not really complicated. As I said, worksheet 5, exercise 2, 2x minus 4y plus 5z equals 33. We rewrite it in a row here, so x, y, z, and our solution here. The second equation, 4x minus y equals 5, so 4 minus 1, 0, because in this case we don't have z, so z is 0, equals negative 5. And the third equation, negative 2x plus 2y minus 3z equals 19, so negative 2, 2, negative 3, and 19. So this is our organized matrix. So you see x values, y values, z values, and here instead of rewriting first two columns, we just write our solutions or our free factors as you wish. And now the question is, what should we do in order to get 0 here instead of 4 and 0 here instead of negative 2? So how can we add these rows together so that our values here be 0? So let's take a look at this. Let's take a look at this 4 first. If you write negative 2 R2, and our R2 is the middle row. So negative 2 times R2 plus 4R1. What would we get? So let's check. Negative 2 times 4 is negative 8. Here we would have negative 8. Here we would have 2. Here we would have 0. And here we would have 10. When we plus that to negative 4, to plus 4, sorry, let's see what we get. So negative 8 plus 8 would give us 0. 2 plus 4 times negative 4 is 16, so 2 minus 16 would give us negative 14, and negative 2 times 0 will be 0, plus 4 times 5, 20, would give us 20. Negative 2, negative 5 would be 10, plus 4 times negative 33 would give us negative 133. Okay, good. Now we have our 0 here, which is what we wanted to. Now let's take a look at this 0. What can we do? Which two rows can we add to each other so that here we have 0? Well, that's easy. Just third row plus second row. Sorry, first row. And what would we have? Negative 2 plus 2 would give us 0. 2 plus negative 4 would give us negative 2. And negative 3 plus 5 would give us 2. And then the solution 19 plus negative 33 would give us negative 14. Good. Now there's only one other that we need to take care of, and that's negative 2 here. We need to do something with it so that we have 0. And there's a little rule. When you have this one here, that last 0 that you have to get, always focus on row 2 and row 3. Don't work with row 1 in that case. And always follow try to follow these steps that I did. So first we solve for this 0, then for this 0, and then for this 0. It will be way easier, I promise you. So once again, we need to do something with row 3 and row 2. Actually, we need to add them in a way that our negative 2 becomes 0. So what would we do? Let's take a look at this. So we can multiply third row by negative 7 and then plus third row to add it to the row 2. So what would it look like? Negative 7 times 0 would give us 0, right? Plus 0 would be still 0. Negative 7 times negative 2 would give us 14, plus negative 14 would give us 0. This is the 0 we are looking for. Negative 7 times 2 would give us 14, plus 20 would give us 6. And negative 7 times negative 14 plus negative 122 would give us negative 24. And now, if you remember this, so these hashtags would be just any numbers that we get. Here we would have 3 zeros, and here we would also have some values in order to get to these equations. And when you take a look, this is exactly what we got. We have 3 zeros, we have some numbers that we got from our calculations, and here we have solutions. So what are we going to do now? Let's calculate for z. So 6z equals negative 24. Z equals negative 4. We take this z, put it in the second one so that we find y value. So negative 14y plus 20 times negative 4 equals negative 22. And then we would get that our negative 14y equals negative 42, which is 3. So y equals 3. And then there is only one more value that we need to find. It's a value of x. So we just substitute the values for z and y in the first one, and we get that 2x minus 12 minus 20 is equals negative 33. When we combine these two together, we get 2x minus 32 equals negative 33. 2x equals negative 1, and x equals negative 1 over 2, or negative 0.5. So our solution will be written as x, y, z equals negative 1 over 2, 3, and negative 4. And that's the solution for this system of linear equations. Guys, from my side, that's all I wanna say in this video. I hope this is at least a bit clear. I don't expect you to figure this out immediately. You need to practice a lot. This is pretty time consuming, but I think that just by following matrix and Cramer's rule, you would probably be fine with the time. So please practice this, let it kind of sink in, and if you have any questions, please let me know. That's all from me. See you in the next video. Bye.